Last week, we reviewed how to solve systems of equations using elimination and substitution. This week, we're going to apply those tools to model real-world situations and to solve these real-world situations using systems of linear equations. So let's start out with a simple problem. Tank A can hold 500 gallons of water. Tank B can hold 700 gallons of water. If tank A drains at a rate of 10 gallons per minute and tank B drains at a rate of 20 gallons per minute, when will the tanks have the same amount of water in them? So do your best to model this using linear equations. There's two tanks, so you'll probably have to create two linear equations to model each situation, and that'll be a system of equations. So pause the video now and see if you can come up with the system that models this situation. Alright, so if you notice, tank A starts out with an initial value, 500 gallons of water. Tank B also starts out with an initial value, 700 gallons of water. All right. The number of gallons in tank A decreases at a rate of 10 gallons per minute, and in tank B it decreases at a rate of 20 gallons per minute. So most of you probably caught on to the fact that because these situations involve a starting point and a rate of change, that slope-intercept form would be the best way to model these situations. And so you should have come up with y equals 500 minus 10x, or you could have had the negative 10x before the 500. But the second equation was y equals 700 minus 20x. 500 is our starting point, or the initial number of gallons in tank A, and it's decreasing at 10 gallons per minute. X is the number of minutes, and y would be the number of gallons after x minutes. And the same logic applies to the second situation. So now that we have two linear functions in slope-intercept form, which of the two methods can we use to solve the system? If you said substitution, you'd be correct. Since this expression and this expression are both equal to y, and we want to know when those outputs are equal, we set the two equations equal to each other, and we find that after x number of minutes, after 20 minutes, the two expressions are equal. And after 20 minutes, there are 300 gallons of water in each tank. So the answer to the question would be, after 20 minutes, there were 300 gallons in each tank. So, just to recap, we looked at a situation. We saw that it could best be modeled by slope-intercept form. By now, we should be very good at doing this. We made our model, we came up with our system, and used substitution to solve our system of equations to answer the question. Now, sometimes it is easier to use the standard form of a linear equation instead of slope-intercept form, because in some situations, the starting point and rate of change are not obvious. Real-world situations that can be modeled using the standard form of a linear equation often describe a total of some kind and involve two unknown values. Consider the following situation. T-shirts at a flea market cost $2 each, and shorts cost $5 each. You have a total of $100 to spend. How many t-shirts and shorts can you buy? The situation can be modeled using the following equation. 2t plus 5s equals 100. Now, why is this? Well, 2t, the first term, represents the amount of money that are going to be spent on shirts. The second term, 5s, represents the money spent on shorts. And of course, when you add the money spent on t-shirts and shorts, you get the total amount of money spent. This is why standard form is used to represent these totals, because the form of the equation is something combined with something else equals that sum, which is a total. Now, just to show you that this is a linear equation, all right, the graph of the equation reveals the possible solutions. When we graph standard form, we get this nice little equation. And, we get this nice little graph. And so you can see it is a linear function. We could figure out what the rate of change is here, but it doesn't really make a lot of sense in the context of this problem unless we're trying to figure out how one variable changes as another variable changes. And really, in this situation, we're not worried about that right now. So reinterpreting this equation or changing its form to slope-intercept form isn't really going to help us. Although we could graph it and find possible solutions to the equation. So for example, 0 t-shirts and 20 shorts would be a solution to the equation. So if t equaled 0 and s equaled 20, that would be 0 plus 5 times 20 is 100. 0 plus 100 is 100. 5 t-shirts and 18 shorts, 10 t-shirts and 16 shorts, etc., etc., etc. So graphing these equations are sometimes an easy way of finding possible solutions. Now, what I'd like you to do is model each of the following situations using standard form of a linear equation and meaningful variables, and then use the equation to find a possible solution. So let me start you out with the first one. Your class is taking a trip to the public library. You can travel in small and large vans. A small van holds 8 people and a large van holds 12 people. If there are 144 people in your class, how many small and large vans will you need? So model this situation and then use the equation to find a possible solution. As you saw in the last example, there might be more than one possible solution. Pause the video now. All right, let's see how you did. So let's first identify our two unknowns. So it says here a small van holds 8 people and a large van holds 12 people. So we know how many people fit into a small van, but we don't know how many small vans we need. All right? We know that 12 people fit into a large van, but again, we don't know how many large vans we need. In fact, that's the question we're trying to answer. So if we want to know how many small and large vans we'll need, those are two unknown variables. All right, to find out or to model this situation, what we need to do is we need to figure out how many people or how many students are traveling in small vans, how many total students are traveling in large vans, and we set that equal to the total number of people in our class, 144. So you should have come up with something like this: 8 times S plus 12 times L equals 144. The number of small vans times 8 people per van plus the number of large vans times 12 people per van equals 144. So that tells us the total number of students in small vans, the total number of students in large vans, and 104 is the total number of students in the class. And so using this equation, we could plug in a value for S and solve for L, and vice versa. I came up with a possible solution of 15 small vans and 2 large vans, but you could have come up with another viable solution as well. All right, let's take a look at a second situation. You have $6 to spend on lunch today. The drinks cost $1.25 each, and the salad costs $20 per ounce. If you spend all your money, how many drinks and how much salad can you buy? So pause the video now and try to model this situation. All right, let's see how you did. So first thing we're going to do is identify our unknowns. What is unknown here? Well, the drinks cost $1.25, but we don't know how many drinks we can buy. The salad costs 20 cents per ounce, but we don't know how many ounces we're going to get. All right, so we need to know the total number of drinks that we order and the total number of ounces. So those are our two variables. And so I came up with $1.25 times the number of drinks gives us the total cost of the drinks, and 20 cents times the number of ounces of salad, and that would give us the total cost of the salad. Total cost of the drinks plus the total cost of the salad gives us the total cost of the meal. And of course, one viable solution would be 2 drinks and 17.5 ounces of salad. Notice the variable d needs to be is limited to whole numbers, but the variable s, the number of ounces, is not, because you can have fractional ounces, but you can't really have fractional drinks. But that's neither here nor there. Okay, so let's take a look at this situation. So far all we've done is modeled situations where only one equation was needed. In this situation, two equations will be needed. So Carl had brochures printed for his new business venture. He originally ordered 4 boxes of black and white brochures and 3 boxes of color brochures, which cost a total of $122. After those ran out, he spent $144 on 4 boxes of black and white brochures and 4 boxes of color brochures. Given that the prices didn't change, what was the price of each type of brochure? Write 2 equations to describe how much Carl spent on brochures. Can you identify the 2 totals? Let X equal the price of black and white brochures and Y equal the price of color brochures. So let's try doing that now. All I want you to do is write the 2 equations, model the situation, and we'll solve it later. So pause the video now. All right, let's see how you did. All right, so the 2 equations I came up with were 4x plus 3y equals 122. So x equals the number of black and white brochures. Remember? The price of black and white brochures. So if you ordered 4 boxes of black and white brochures, then the total cost of black and white brochures would be $4 times the number of boxes. All right, the number of colored brochures that he ordered was 3, and the cost is y. So this term tells us the total cost of color brochures, and so in this situation, when you order 4 boxes of one and 3 boxes of another, you get 122, or it costs $122. All right. Next, he ordered 4 of each, and that cost $144. Now, if you notice, this situation gives us 2 equations in standard form, which implies that if we want to solve the system, we should probably use elimination. So let's go ahead and use elimination and try solving this system now. All right, so we can't really combine the 2 equations yet. So what I'm going to do is I decided to multiply the second equation by -1. You could have done the same with the first equation. Many of you probably did that to avoid negative numbers. I did not. So that leaves us with negative y equals -22. Multiply both sides by -1, you get y equals 22. All right, plug that back in, and you get x equals 14, which leads us to the conclusion that Carl paid $14 for each box of black and white brochures and $22 for each box of color brochures. In this problem, Ava has $10.25 in quarters and dimes. She has a total of 65 coins. How many of each type of coin does she have? The 2 unknowns in this problem are the number of quarters and the number of dimes, so I'm going to use the variables Q and D to represent those 2 quantities. My first step would be to write 2 equations that express the relationships in the word problem. There are 2 basic ideas here. The amount of money Ava has, which is in total is $10.25, and the total number of coins she has, which is 65 coins. The 2 equations I came up with are 25 cents times the number of quarters plus 10 cents times the number of dimes equals the total amount of money Ava has, $10.25. And of course, the total number of quarters plus the total number of dimes equals 65. Now, I'm going to solve the system of equations and find the value of the 2 unknowns. I have 2 methods available to me, substitution and elimination. The first method I'm going to use is substitution. So I'm going to take this first equation and I'm going to solve it for D. This way I'm going to describe one variable in terms of another. I've solved that first equation for D, so D equals 65 minus Q. I should mention that I could have solved this equation for Q, but I decided to solve it for D. It'll work both ways though. Once I've described D in terms of Q, I have an expression, 65 minus Q, that describes D. So I can substitute 65 minus Q anywhere I see the variable D. So I'm going to take the first equation, and I'm going to substitute 65 minus Q in for D. When I solve that equation, I find that Q equals 25. Now I'm not done because I need to find the number of quarters and the number of dimes. So I'm going to use the quantity 25 and I'm going to substitute that back into Q in both equations. And when I do that and solve for D, I find that D equals 40 for the first equation and D equals 40 for the second equation. So I can come to the conclusion that Ava has 25 quarters and 40 dimes. Instead of using substitution, you might have also used elimination to solve this system. Now, there's no one way to solve using elimination. The method I'm going to use is just one possible way, but we know that the main idea is to eliminate one of the variables. So to accomplish this, the first thing I did was multiply this first equation by -4. When I do that, I turn this 0.25q into a negative q. Then the 0.10d turns into a negative 0.40d, and this 1025 turns into a negative 41. Then I'm going to take my new equation and I'm going to combine it with q plus d, and when I do that, I eliminate the q's. Negative q plus q is 0, negative 0.40d plus d is 0.60d, and negative 41 plus 65 is 24. Solving for d, I find that d equals 40. Now, I already know from the last example that I'm correct, but just to make sure, I'm going to substitute 40 back into both equations to solve for q. And when I do that, I find that q equals 25 and q equals 25. So I'm confident in saying that Ava has 25 quarters and 40 dimes. Let's take a look at another example. In this example, Beirang has $175 in denominations of $5 and $10 bills. He has a total of 28 bills. How many of each type of bill does he have? So the two unknowns in this problem are the number of $5 and $10 bills. Let's use the variables f and t to represent the number of $5 bills and the number of $10 bills. So for step 1, we're going to write two equations. One equation will express the total amount of money Beirang has, and the second equation will express the total number of bills he has. Now, why don't you pause the video and try to write these equations down yourself. Pause the video now. All right, let's see if you came up with the same thing I came up with. So to express the total amount of money Beirang has, I'm going to multiply $5 by the number of $5 bills he has, plus $10 times the number of $10 bills he has, and we know that that equals $175, the total amount of money Beirang has. Now, to express the total number of bills Beirang has, we add the number of $5 bills to the number of $10 bills, and now we have two equations. To solve this system, we can use substitution or elimination. The first method I'm going to use is substitution. So I'm going to solve this second equation for f. I could have solved for t, but I chose to solve for f. So f equals 28 minus t. Now I can substitute 28 minus t in for f in the first equation. And when I do that and solve for t, I find that t equals 7. But of course, I'm not done because I've only found the value of one of the variables. So I'm going to substitute 7 in for t into both equations. And when I solve for f in both equations, I get 21 and 21. So I'm very confident in saying that Beirang has 7 $10 bills and 21 $5 bills. Another way of solving the system is by using elimination. I'll first start out by multiplying this second equation, f plus t equals 28, by -5. When I do this, I get -5f minus 5t equals -40. I did this because when I combine the two equations, 5f and -5f cancel each other out. I've eliminated one of the variables. Then 10t minus 5t is 5t, and 175 minus 140 is 35. Dividing both sides by 5, I get t equals 7. But again, I'm not done because I have to substitute 7 back into both equations to find the value of f, the number of $5 bills. And when I do that, as expected, I get f equals 21 and F equals 21. So I'm confident in saying that Beirang has 7 $10 bills and 21 $5 bills.